Welcome to my channel, Engineering Lectures Made Easy. Hello everyone. Today in this session, we are going to discuss Banker's algorithm. So Banker's algorithm is a deadlock avoidance algorithm. So let us see a scenario where the deadlock condition exists. So here we have two tasks which we can refer to two different processes, and we have two resources, namely printer and a scanner, which can be termed as two resources. Now task 1 is holding a resource type printer and it is requesting for a resource type called scanner, and task 2 is holding a resource type scanner and is requesting for a resource type printer. So this scenario, when neither of the processes deallocate one of the resource, the other processes cannot be satisfied with the requesting resources. So this particular condition is a deadlock condition. So let us move on to the definition of the deadlock. It's a set of block processes, each holding a resource and waiting to acquire a resource held by another process in the set. So this condition is called a deadlock condition. So we shall see a real-time scenario of deadlock condition which depicts the traffic jam condition. So here you can see that there is a junction and there are four roads across the junction, and four roads can be termed as resources, and the cars which are moving on the roads can be termed as the processes. So here in this condition, neither of the cars are able to move forward in any of the direction because of the deadlock state, unless one of the car in one particular direction makes way for the other to move across. The scenario, the complete system is in the deadlock state. So understanding this, we shall move forward for our actual algorithm on deadlock avoidance technique, which is the Banker's algorithm. This Banker's algorithm was proposed by Dijkstra to regulate the resource allocation and to avoid the deadlocks. So the Banker's algorithm is also best known for its avoidance technique. So here we have multiple instances of resource type and processes, and each process must claim its maximum use in prior. And when a process requests a resource, it must have to wait. When a process gets all its resources, it must return them in a finite amount of time. Now we shall move on to the data structures for the Banker's algorithm. There are basically four data structures what we use for solving the Banker's algorithm, namely available, it's a vector of length m; max, it is an n cross m matrix; allocation, it is an n cross m matrix; need, again it is an n cross m matrix. So all these data structures we will be understanding in detail when I take up the analogy of Banker's algorithm. We have the next algorithm which is called as safety algorithm. So the Banker's algorithm is basically divided into two sub algorithms. One is the safety algorithm and the resource request algorithm. So what is the safety algorithm? There are basically four steps with respect to safety algorithm, and we have around three steps in resource request algorithm. So in detail, we'll understand the algorithms after knowing the analogy of Banker's algorithm. So now let us have a scenario where let us say that you have got three friends, person A, person B and person C, who are in need of amount in the form of loan. Now there's a depiction of the friends here where I have named them as A, B and C, and they're in the need of amount at that particular point of time. Now you have rupees 24 with you. Now a person A needs rupees 8, person B needs rupees 13 and person C needs rupees 10. So now you have lent rupees 6 to person A and rupees 8 to person B and rupees 7 to person C. So altogether, when we calculate the remaining amount with you, so out of 24 rupees, you have lent 21 rupees. So totally, you are left with rupees 3 in hand. So this particular scenario gives us an analogy of understanding the different data structures in the Banker's algorithm. So even after giving 6 to person A, he still needs 2 because the maximum need of person A is 8 and you have given only 6 rupees at time T naught. So Even though you have lent 8 rupees to person B, he needs 5 more. And person C needs 3 more because you have lent only rupees 7. So in this particular stage, until they get the amount they need, they can neither do whatever task they have or not return the amount they have borrowed. So this is a particular scenario where we will get to know that the resources has been allocated to the processes, but the process has a maximum need of some other value which should be satisfied for the process to get executed on the CPU. So the available options to solve this problem is you can give rupees 2 to person A and wait for him to get his work done and then get back the entire 8 rupees because A needs 8 rupees. So totally you can give 8 rupees to him and get back the remaining amount so that you can satisfy person B and person C's request. So whenever you're doing in this particular way, so this state is termed as safe state, where everyone's task is completed and eventually you get all your amount back. This is one scenario where the system is in safe state. So relating this to a particular processes, so processes are requesting the resources. So requesters are the resources are allocated to processes such that the system will not go into a deadlock condition. So moving forward for the second scenario, where actually there exists a problem called as deadlock. So here, knowing that person B needs rupees 10 urgently, instead of giving 8, you end up giving 10. Okay. So in the previous scenario, we were left out with rupees 3 in hand, and but person B is asking 2 more rupees, which is total amount what he requires is 10 rupees. So a complete 10 rupees is given to him. So we are left out with only rupees 1. So in this particular state, person A needs 2 more rupees, and person B needs 3 more rupees, and person C needs 3 more rupees. So neither of the processes can be satisfied at this condition because we are only having a resource of 1 in number. Now, you don't have enough money to give them, and until they complete the task, they need the money for. No money will be transferred back to you. So, this particular scenario where you are not left with any of the resources in hand to satisfy any of the processes until a process gives or deallocates its resources. So, this particular condition is called as deadlock condition. So, this situation is called an unsafe state or deadlock state, which is solved using Banker's algorithm. So the goal of Banker's algorithm is to handle all requests without entering into the unsafe state, also called a deadlock state. Okay. The money lender is left with not enough money to pay the borrower, and none of the jobs are complete due to this insufficient funds. Okay, so it's called the Banker's algorithm because it can be used in the banking systems so that banks never run out of resources and always stay in a safe state. So, coming to the different things we are supposed to do to work on with Banker's algorithm, we have basically three terminologies here. One is the max, allocated, and available. So, max is how much of each resource each person pulls maximum request. So, in our basic example, we had that person A needs totally 8 resources or 8 rupees. Person B needs 13 rupees. Person C needs 10 rupees. So this basically we can term it as max. This is the maximum amount of resources the process might require to complete this task. Okay. So coming to the second point, it is how much of each resource each person currently holds. So this is termed as allocated. So here in our example, we have seen that at time T naught, a person a is allotted with 6 rupees, person B is lent with 8 rupees, and person C is been lent with 7 rupees. So this particular variables we can relate it to the term allocated. And coming to the third point, which is available, how much of each resource is available in the system for each person. So after lending a particular amount in the first scenario, we are left with 3. So this is the available amount or available resources in terms of processes. So in the second scenario, we were left with only rupees 1, which is the available resources. So now, so how do you calculate the max and need? Okay. So if request is given, then max is equal to allocated plus request, and need is maximum minus allocated. So these are the two formulas we are supposed to know to solve the numerical. And you should also satisfy a condition such that request should be less than or equal to available. So in our analogy, if available amount is rupees 3 and if the request is rupees 5, so in this case it is not being satisfied. So we cannot go with the uh, for moving forward, we cannot go with the next stage of solving the Banker's algorithm. So this is the condition we should always satisfy. Thank you for watching this video. Subscribe for my YouTube channel for more tutorials on operating system and other computer related subjects. And in our next video, I'll be solving a numerical on Banker's algorithm. Thank you, Ananda.